Hi, my name is Uchenna, and today I'll be solving Leetcode problem 160, intersection of two linked lists. Alright, so for this question, we're given the heads of two singly linked lists, head A and head B, and we want to return the node at which the two lists intersect. The two lists have no intersection, we just return null. For example, the following two linked lists begin to intersect at node C1 over here, and it says the test cases are generated such that there are no cycles anywhere in the entire linked list structure. So we don't have to worry about cycles being in our linked list. It says here to note that the linked list must retain the original structure after the function returns, meaning that we can't do any modifications such as deleting elements or deleting nodes from our linked list. And here's just some things about how the code will be judged. For example, the intersect value, list A, list B, skip A, skip B. For the process, or for the purpose of solving this question, we don't really have to go over this, but in your own time, if you feel the need to really understand the internal workings as to how Leetcode is evaluating your solution, you can go ahead and try to understand this. But let's jump right into the example. So for the first example here, we see that the intersect value is 8, meaning that it has a value that the two lists intersected at over here, and the two lists that were given are 4, 1, 8, 4, 5, and 5, 6, 1, 8, 4, 5. And as you can see, there's an 8 here in list B, and there's an 8 here in list A, so we just return true as the question asked. Similarly, for this example here, the same case, both lists intersect at node 2, but in this example here, there's no intersection, so in this case we would want to return null as the question asked. So how can we solve this? So similarly to the last video I did about how we can detect cycles in a linked list, there are two primary ways to solve this question. One being using auxiliary data structure such as set, and storing the memory location of every node that we hit, and then checking if we see a particular memory location on either lists. And as shown in my previous video, that kind of approach does take extra space, so it's a little bit inefficient when it comes to the space complexity. Now, how can we solve this knowing that we want to optimize our solution for space and time? In order to do this, we can iterate through both linked lists and find the lengths of both respective linked lists. Now, once we do that, we know that in order to simultaneously iterate through both of our linked lists at the same time, the difference in lengths must be the same, or there must be the same length, right? If we want to optimize this solution for time complexity. So once we find that difference in length, we can simply shift the pointers to start at the same positions relative to each linked list, and then we can iterate through both linked lists simultaneously, and if any point in time our pointers meet, then we know that there's an intersection in the linked list. So what do I mean by this? So you can see here in example 1 that we have a linked list B and a linked list A, and the length of B is actually 1 greater than A. It has one extra node, B1, than A. So based on that, rather than starting to iterate from B1, we can iterate from B2 as well as iterate from A1, and do this simultaneously. And when we do this simultaneously, we know that at some point in time, both pointers will meet at node C1. This approach ensures that we don't use any extra space and is very optimal for solving this question. But it does take a little bit of hoops to jump through to reach that stage. So let's start by coding this. So I'm gonna have a value here called difference, and P1 equals head A, P2 equals head B, and we want to get the length of A and len of B. Okay, so while P1 is not equal to none, P1 equals P1 dot next, and len A plus equals 1. When we get out of this loop, I'm going to reset P1 back to head A. I'm going to repeat the step for our pointer 2 to get the length of both linked lists. P2 equals head B. Okay. So now that we have the length of both linked lists, it's a simple check that we need to do. So we know if length of A is greater than length of B, then the difference is going to be len A minus len B, right? And once we calculate the difference, we just need to move our pointer that is at or our pointer 1 to match this difference. So how do we do this? So say while difference is greater than 0, we just move our first pointer. So P1 equals P1 equals P1 dot next, and difference minus equals 1. And in order to be consistent, we do the same check, but for our for the opposite condition. So we want to check if len A is less than len B, or to be more explicit, if len B is greater than len A. Then in this case, the difference would be len B minus len A, and we do the same process again. So we change P2 to match the difference, and once we've done these preliminary checks, now we can get to the heart of the algorithm. So this is just iterating through both linked lists simultaneously and checking if either pointer meet at some point. So to do this, you say while P1 and P2, if at any point P1 equals P2, return true, else P1 equals P1 dot next, P2 equals P2 dot next. And if we never find an intersection, just return false. So this is a bit of a lengthy solution, 53 lines of code, but it's very intuitive in the sense that I took you through the solution step by step as to what you need to do to reach the solution, and it can be broken down into 3 parts. So the first part is to find the lengths of each linked list. The second part, we want to adjust pointers based on the difference in the length of the length. Then the third part is going to be find the intersection by simultaneously iterating through both linked lists. So that's basically what we need to do for this algorithm. And if I run this, let's see how it performs. So what did I do here? Attribute bool has no attribute val. Oh, so we have to return the node which the two lists intersect. So what I did wrong here is just I need to just return p1 or p2. Either one would work. And rather than false, I just return none. So let's run this one more time. And it passes all the test cases. So this is a working solution. And as I said, the time complexity for this solution will be O of n. And the space complexity will be O of 1. As we're not using any auxiliary data structures, we're simply just using plain pointers. And let's submit this code and see how it performs. And this works. So yeah, I hope this helps you solve any queries you might have about this question. If you have any underlying questions still after watching this video, please drop a message in the comments. I'm very active and I'll be reading the comments and do my best to solve any questions. And don't forget to leave a like and hit the subscribe button, and have a good day.